Hi, all. I'm Dan Smigrod, founder of the We Get Around Network Forum. Today is Thursday, September 27th, 2018, and you're watching WGAN-TV live at 5. Our topic today for Matterport service providers, how to make money with Matterport meets AEC space for newbies. And our guest today is Paul Tice, is the founder and CEO of Topa 3D. In the Portland, Oregon area, and working out of the I want to say Bend, Oregon right now. Paul,
Yes,
good to see you.
Hey, nice to see you too, Dan. Thanks for having me.
You bet. Thanks for being on the show today. We got a lot of stuff to cover with Paul. If you have Matterport, maybe you've been scanning houses, you keep hearing these initials, AEC, architects, engineers, and construction. How do you make money? What problems do you solve in this AEC space? Who are the potential clients in AEC? Who are the stakeholders, the people you might talk to in AEC? What's the use case for Matterport in this AEC space? And we're going to even talk a little bit about the lingo because it's a little bit crazy. MEP, Faro, BIM, Revit, as built, etc. So Paul is a subject matter expert on all of this stuff. So excited to have Paul on the show. Paul, let's talk a little bit before we jump into the topic and cover this. Let's just talk a little bit about you because I'm really excited about even just your credentials. You're teaching a class on lynda.com/LinkedIn Learning.
Yes. Yeah, yep. That's been a lot of fun. LinkedIn, I was speaking at a virtual reality meetup and showed some Matterport and showed some photogrammetry models that we had been making with drones and so forth. And I was headhunted a little bit and they said, would you like to teach for LinkedIn? And I said, absolutely, yes. So it's just a great environment. So I've been able to, get the message out of how to use some of these tools. The tools are transforming so quickly. Every 6 months, there's a brand new innovation, at least sometimes every month. And so, my thinking is there's no sort of hold on the data. There's no reason to keep it safe and sort of as trade secret because, if somebody given enough time can learn it themselves, I just want to fast track that for them because, that's how I learned. There's a lot of generous people on YouTube and different places that I was able to learn from to do a lot of this stuff. And I'm always learning. So it's a really neat environment to sort of give and trade information between service providers and software companies and things like that.
And the title of your class, Matterport 3D Scanning and Visualization. So you can find that on lynda.com, lynda.com, or on the LinkedIn Learning classes. And why don't you talk a little bit about what you do with your business? You're the founder, CEO of Topa 3D, based in Portland, Oregon. What's the specialties and some of the things that you do so that we have context for today's show?
Well, what we do is reality capture. So the concept there, which is a big buzzword with Autodesk communities and all that sort of thing, is we use sensors or 3D scanners, drones, any kind of sort of visual capture device to document spaces and places. So the thing that separates a photographer or a drone pilot or these types of people apart from people in this industry is that we capture data that is measurable. So when we're creating a space in 3D, we're doing it with measurable data. So we're using infrared sensors, as like on the Matterport camera, or we're using GPS sensors on the drone to geotag the images to make accurate models to some degree, or we're using control points from surveyors out there in the field to line up all this data. So, reality capture is a pretty big sort of bandwidth of technology, but at the end of the day, it's using anything from a smartphone to a several $1,000 scanner to capture a space so that somebody can use that to make a decision or to understand something in a way that is difficult to do without some sort of context, like either physically walking the space or something. So it's just a really amazing tool, and we find a need for it in a lot of different markets, including probably primarily the AEC market.
Mm-hmm. And so folks in the AEC space would either engage you as to capture reality as a consultant, and then maybe there's others that engage you for running workshops, training, even universities, nonprofits, et cetera.
Yeah, that's right. So I've kind of run the gambit in this industry quite a bit. I've seen a lot of different venues who are interested in the technology. I sort of started doing historic preservation work with 3D scanning using a Faro scanner, a photon. And I learned a lot about historic preservation and what they're after. And at the end of the day, a designer or some people like this, they want to see it, but they also want to do something with it. Very few people just want to have a visual unless they're maybe a real estate agent or something like that. So I started with historic preservationists and nonprofits. I did a lot of pro bono work just to sort of market and drive the industry, market the technology. And I did a lot of presentations with that. I was doing some animations with point clouds, which is a data type that's generated from either 3D scanners or from photos, like from the Matterport scanner. And so doing some creative things like that. And that sent me to the Bentley Be Inspired competition in Amsterdam. And our company won first place to show how we could use matter tags, or excuse me, I want to say Matterport. But using scanners or point cloud data to visualize spaces in a very fast and multimedia sort of way, kind of using animations and things. And they had never seen that. So that was kind of a turning point for me, winning that award with the team. Our team collected the data, and I processed some of it. I did a lot of the animation work, so it was a team effort. But what happened after that is we were invited to speak at conferences about point cloud data and scanning and all things reality capture. So I started traveling. That was back in 2012, I guess it was. And from that point on, I was connected with new people, people in the real estate industry. I was connected with University of Oregon, various schools, Oregon State. And I did some co-teaching at the master's level for historic preservationists to expose them to the technology with Dr. Lauren Alsop, who is an architectural conservator who's based out of Scottsdale, Arizona. She was amazing to work with. Still is, and she did some conservatory work on the Titanic, and so she has some really neat credentials and exposure to different technologies as well. So I guess, moving through this industry, I've been exposed to a lot of different 3D tech, and now the big thing is virtual reality and augmented reality, and Project Tango is kind of moving towards AR kits and these different development options. And at the end of the day, what people really wanted is a way to see and visualize this data and work with it, but in a lightweight fashion. So just backing up a little bit, talking about the trend of the industry, it started with this 3D scan data that was really large data files, several gigabytes. Most of the software on the market, CAD software, couldn't really handle it. So you'd get crashes. The little Windows icon would just spin and spin and spin, and you're hoping that it's going to kick in, but it never does. And so it was really disappointing because we had this really great hardware, but the software hadn't caught up to it yet. And one of the things you could do with scan data back, 9 years ago, is you could make little virtual tours, but there was really no way to host it. And unless you had a sort of supercomputer, nobody could really use it. So the historic preservationists didn't usually have the technology readily available to be able to even work with the data or figure it out. So then we had to learn how to convert it into something that made sense for them, like into a CAD drawing, a simple 2D CAD drawing. Like, we're taking this massive amount of useful data and we have to dumb it down into something that's so simple that it almost seems like a waste of money and time, because of the deliverable. You could almost do the same thing with a laser meter that costs a couple $100 at Costco or something. But eventually the software started catching up, and the algorithms got more powerful, and the visualization render engines and so forth started becoming pretty robust. And then a handful of years ago, Matterport came on the market. And I was watching I think a Redfin advertisement on television, and I saw, they didn't even talk really about it. It was just going in the background, but it was a dollhouse and it was spinning around. And they're like, contact us today to buy a home or something. And I was just fascinated. I'm like, what is that technology, that they're using on this commercial? And it was Matterport. So when we learned what it was, we started hunting down ways to get a hold of one of these cameras. We ended up buying one, and we started using it and learning how it works. And it works very similar to the scanners we were using, but the really great part about it was, as everybody knows on this, watching this probably, is that it just made it so simple to use on an iPad or even a smartphone. It totally democratized 3D modeling. So everybody could get access to it and really, really understand space. And in that way, it was a game changer. And then what we've seen is that some of these scanning companies are trying to find ways to make their data smaller so that it can fit onto this kind of platform. So now enter the Leica BLK360 from, and potentially the RTC360, the new Leica scanner coming out, is looking at having integration into the Matterport Capture app, because they understand that people really do want to see their spaces in a way that's intuitive and simple so they can make decisions. So it's just been a really amazing evolution, of how this all came about.
Yeah, it's very exciting. I think maybe it's almost like two railroads crossing the country here. Here you have maybe a low end scanner, Matterport, that is really has been about the photography. And then over here you have these Lidar, these really expensive things that have always been about the data. And now the data cameras have the photography, and the photography has the data, and somehow they're kind of coming together. And it's blurring in terms of what these different technologies are and how they get used, which I actually think probably brings us to this AEC space, is to say, oh, okay, because you've been you have the benefit of maybe being bilingual or trilingual, that you are you speak the AEC world, you speak the Matterport world. Now they're all kind of blended together. If I'm a Matterport service provider and I keep hearing these initials AEC, what are the opportunities for making? How do I make money in the AEC world? And I thought maybe we'd just start with maybe go through each of the stakeholders and what problem that Matterport solves for them.
Yeah, sure. There's actually a developing laundry list of that. There's so because I came from this terrestrial high-end LiDAR 3D laser scanning sort of process, we learned that the AEC, or the architecture, engineering, and construction industries, they have a need to have a measurement, or an as-built is what they call it, or some have said as is. Ken Smertz, I think, might have coined that from Eco3D.
Maybe what we do, because I think there's a lot of terminology in this space. If we're a newbie to this AEC space, and you tell me as built, I got to stop you and say, what is an as built? What is that?
Sure.
Because it's important to understand that.
Absolutely, yeah. An as built is essentially an architectural drawing that represents the space as it is today. So when an architect or somebody goes into a space, they usually historically would hand measure everything, or use laser meters or something to get accurate dimensions of that space. Ceilings, floors, walls, and even pipes, like documenting where the pipes or what we call the MEP systems are, the mechanical systems, like the HVAC units that carry air, the electrical systems, all the conduits that hold the electrical, and the plumbing systems, where all the pipes are for that. So they need to know where all that stuff is, because a designer that's going to remodel a space, which is the primary need for as-builts, in most contexts for construction, is they need to know where things are so they can plan what they can leave behind, what's still in good shape, and what they have to wreck out, and what they end up destroying or pulling out of the building, how that's going to affect other systems. So that they just need to know where everything is, so they can plan how they're going to redesign that space and use kind of what's left of it when they're done.
So if I'm hearing you correctly, that a building that's about to go under a renovation, you might say, well, let's just go back to the CAD file for that building. And I think I'm going to say probably the answer is, well, many buildings don't have CAD files, and
Yes.
Even if they did, it probably changed since the time the building was originally. That's the problem.
That's the problem. The what they call the as-built documents, or the existing architectural drawings that they have, are not truly as-built most of the time. And like you said, they may not exist. So especially historical buildings that they're going to renovate, which they're doing a lot of on our university campuses here in Oregon, because they're historic brick buildings and the exterior is nice, but the interior needs a revamp, you know? So the drawings, sometimes these buildings have been remodeled many, many times over the years, and some of the buildings are 100 years old. And so the drawings may or may not reflect what's really there. So, and another thing to point out is these MEP or mechanical electrical plumbing systems that make a building breathe, you know, to keep it alive. Those systems are obviously complicated because you have pipes going in all kinds of directions. But they're also, there's plentiful. Like, you know, you could have mechanical rooms full of pipes and coolers and heaters and boilers and all this stuff. And it can be a sort of a spider web of, you know, geometry, as we might say. And so hand measuring all that and trying to figure out exactly where that's at and how far it is from the wall so they can fit something else in there, like a new product or a new pipe or something. It takes a long time, and there's a lot of human error that can come into that. So enter the world of reality capture or 3D laser scanning, you know, because a scanner like Matterport, it can create a full 3D representation relatively accurately of a space in just a minute or two. Now the Matterport cameras are down to seconds with the new firmware. So this is just a really awesome way to get data in the field. But the trick is getting that data to the client so they can use it for something. So that kind of segues us into this new thought of taking, you know, the existing data in the field that we collect with these scanners like Matterport, and we convert it into something that can be used by the client. And in some ways, Matterport helps with that too, because they kind of have an end-to-end system where they capture and show the data in their own cloud software that you can actually take some measurements from. And you can also download some assets, which we can talk about a little bit later, and use those for AEC applications.
Okay, so we'll talk about Matterpack a little bit down the road, but I think just really to identify the stakeholder and the problem, and the first problem is for anyone who's involved in this project is there's no existing as-built, means the architect has to come in, measure, take pictures, reconstruct the space, because in this world today, we operate in 3D modeling.
Yes, it can take weeks.
Weeks. So the problem that a Matterport photographer, a Matterport service provider can solve is literally within a day or two, turn around what used to take weeks for an architect to reconstruct. So, and I would imagine that is both time and money.
Absolutely, you know, thousands of dollars. The thing about when we talk about saving time and money, and we talk about use cases of this, yes, in this case, two things are really important for renovation with Matterport is that they get this visualization so they can understand the space, just understand the space that, you know, spatially they can see it. And then they can pass that information to all the stakeholders or all the subcontractors, that even the painters and the carpet layers who are going to be working on that space. And so they all understand the space very quickly and what might need to be done. And so it's also a bidding tool. It's a tool they can use to actually make a bid on a project, because they can take rough measurements of that space. Now, the second thing I want to bring up to that point of rough measurement is that Matterport has an accuracy of about 97 to 99%. I've seen up to 3% margins of error in Matterport when you stitch the scans together. And that's important to really recognize, because most of the time it is about 1%, as they say on the website, but sometimes it's more than that, especially for really large spaces or spaces where there's not a lot of connection, like you're going around a building and you try to loop on itself. Sometimes that you won't even really perceive that error. But when you pull it into a CAD model, it'll become clear what's wrong, you know, a square CAD model, for example. So knowing that, knowing your tools, knowing your equipment and how accurate it is can help drive you into the industry and sell the tool correctly. You know, we have ran into situations where we thought Matterport would be a good tool for the job, and the accuracy wasn't really where they needed it to be. We hoped it would be, but it wasn't in the early days. So we had to redo the data, with a terrestrial scanner, and reshoot the whole thing. So that's another time waste on our end. So it's really important when you're going into these use cases, which I'll talk about a few more, but in this case, like for renovations, to really ask how accurate do you need the data? And if they're telling you an eighth of an inch or a quarter inch, you need to move to a different system, But if they say 1 to 2 inches is fine, you just need to know the space, then Matterport could be a really, really great option for you.
Comment on this. What I usually tell people when they say how accurate it is, I generally will say Matterport is good enough for an architect that wants to sketch out ideas of an existing space. And so it's a easy, fast, and quick way to get the underlying 3D model, the as is, to build on top of that to sketch out. Then the data is good enough for quoting on projects. So if you're asking subcontractors to bid on the flooring, the measurements are probably good enough to how much floor covering, how much wall covering, how much paint, etc. But if you're going to need trying to fit some pipes together, then it's probably not the right solution. And if you're cutting glass based on this, don't do that. If you're trying to, but generally the trades do their own measurements anyway, regardless of who does the measurements.
Sure.
So what would be an example? Can you give just one more example of something where you need the precision in AEC where it would be obvious that Matterport would not be the right solution? So don't go there.
To document MEP systems, where the architects or the designers need 1 or 2 inches of clearance, in their design, those kinds of applications at really tight precision, not a good choice. Also because Matterport doesn't return data on black objects very well, like black pipes, and a lot of plumbing and stuff is black by nature. It's wrapped in something, and so you just may, or even areas where there's a lot of reflective surfaces, like a data center type of situation, like a silicon wafer manufacturing facility, where there's a lot of shiny objects, like everything's a mirror almost. Not such a good plan either. Even regular scanners struggle with that. So thinking about accuracy and thinking about the type of materials you're going to run into in that environment can drive that decision as well.
Mm-hmm.
It was really designed as a real estate tool, and they found that it actually could be used as an AEC tool. So the AEC community is vetting that for different use cases, and as I mentioned, those are kind of what you want. But if it, like you said, if it's a rough in, if they need rough measurements, if it's a pretty opaque surface, like just regular paint, things like this, not shiny, not too black, and the precision is within inches, not millimeters, then you're probably okay to try it out. Also, the thing you want to think about, last thing on that, is security. So a lot of AEC jobs have a high degree of security required to work on that job. You have to sign a non-disclosure agreement and all of that, and carry a whole ton of insurance. So we can talk a little bit about the business model of Matterport for AEC in a little bit, but the idea there is that you just have to kind of know what you're getting into with that environment. And Matterport hosts the data on the cloud, and not every contractor is going to be savvy to that. Some clients or owners of buildings don't want their stuff out in the Wild West that anybody can look at. And Matterport doesn't have a local solution yet.
Yeah,
so that's,
and I think if I'm a Matterport service provider and I'm scratching my head wondering who I could talk to that's AEC, architect, engineer, construction, I'm probably not going to go after the CIA, the NSA, the FBI, the military.
right.
And there's probably some commercial construction where their buildings are 50,000 square feet, 25,000 square feet, and maybe a lot of these issues related to security and cloud maybe become non-issues. The architect or even the general contractor is looking for a way to say, or the client, how can I get to as-built as fast as possible, the as-built drawings, the as-built CAD, how can I get to that as fast as possible at the least amount of expense? And also, I think maybe be a little bit more accurate than even an architect coming out and measuring, because I'm going to guess, correct me if I'm wrong, but if you have all these odd shapes in a building, you can't possibly measure so you're going to take key measurements and you're going to smooth out that line and say, this wall goes this way, and I'm not going to measure every I'm just going to say, oh, straight line, and I'll note it on the drawing, right?
That's right.
Where Matterport's actually going to capture all the, whatever the right word would be, the undulations of that space.
Yes.
So anyway, so that's kind of architect. Let's go into maybe who else is a stakeholder here that what problem do you solve for them?
Yeah, so we do find that hospitals have been a really great client of ours because hospitals do remodels all the time. And so as in the AEC environment, we've just finished up 2 really large hospitals. We did one that was 75,000 square feet and another one that was over 160,000 square feet. And we had 2 Matterport cameras going at the same time on 2 different floors. And we're pushing out these massive models with 500 plus scans. We probably did 5,000 scans over the period of a week with the Matterport. So, we really pushed the limits of it. And I think that is something that you should consider if you're going to be in the AEC industry, is that these spaces are typically going to be pretty large if you're going to go into commercial scanning. But, Matterport can handle between 200 and 500 scans pretty well. I've even heard that one guy got 1,000 scans to process through the cloud, although sometimes that may or may not work.
I'm imagining that you did this, treated each floor as a separate Matterport scan.
Yeah, and then we linked them together with the Matter tags. So the Matter tags are a really handy tool because you can put the link of one model in the tag, and it'll show a movable thumbnail of the other Matterport model inside of that view. So you can jump between floors. As we get to the end of a corridor, we just have the Matter tag sitting there, and then they can jump to the next floor up the stairs through that tag, right?
Great. So that is really actionable information. That's really awesome. Yeah.
It's really neat. Yeah, we found some creative. We also did some PDFs, an overview map of all the floors sort of stitched together using Photoshop, and made a PDF and linked that. We hosted on our Amazon server, Amazon web server, Amazon S3, and then we link it from Amazon to Matterport, and they can see the PDF map show up on a Matter tag as they first enter the space and say, oh, where am I? And we have it highlighted in blue where they're located on that map. Mm-hmm. So just these little ways of creatively linking models together so that people can feel like they're going to stay in the experience as they navigate that space, rather than having to jump out, go to a web browser, jump back in. We try to keep them in there.
On the 160,000 square feet, how many square feet per floor did that work out to about?
I think it was about 40,000.
40,000. Did you feel that was pushing the limit of 40,000, 500 scans?
What happens, what we found in the app is that we started getting some drift and the corridors started bending, especially long corridors. And so we'd back up, delete the scans, and then try to scan again to try to get a better connection. And we never really could completely get rid of that. But when we processed it in the cloud, it actually straightened it out. So we got lucky, I think, because there's no prediction on how that's going to work. But in this case, like I mentioned, the accuracy, if I've measured end to end of that large building, is probably not that great because it's so many scans, and there's who knows where that drift is happening in the data. But it gave them a really great context of all these, there was hundreds of rooms and labs and clinic rooms and things like this. And they really loved it because they sent that out to all their subcontractors of like estimating paint, estimating flooring, estimating, all these kinds of things that need to be done to that building. And just invaluable because otherwise they'd have to try to get a Revit model, which Revit is architectural modeling software that's made by Autodesk. And it's a standard for the most part in North America, and some would arguably say in the world, to create 3D models for architects, because these models that are built inside of this Revit platform from Autodesk have what they call intelligence or metadata that's attached to each of those model components. So a wall, if you click on a wall, it'll tell you all about that wall, if it's gypsum, who made it, when it was made, all this stuff, right? And so it's a really amazing design platform, and it's kind of database driven, but it's got visual as well. So what they typically would do is they try to, hand measure the whole space, and then they try to build this rivet model if they're, because there probably wasn't one already created. They just had architectural drawings. So they had to recreate a model from the drawings, which takes weeks. And then they would have to somehow give that to subcontractors and hope the subs actually use Revit. And if they don't, then they have to convert it to a CAD file to try to get them to use it and make sure it's in the right version. And I mean, it's just an ongoing thing, short of getting people all in the same room or looking at the same screen on a webinar. It's difficult to share that information. But Matterport totally democratized that. And I gave everybody permissions to that Matterport job on the cloud. I made them collaborators so that everybody could go in as an editor that mattered. I mean, we only had about 6 editors and the rest were viewers, but they could go in and take their measurements and figure out what they needed to do and tag it up and send links to other people. We actually linked it to box.com. We took photos of all of the outlets and some other things that was important for the job. And we linked those photos to matter tags inside the model so they could see what the camera didn't catch. What the Matterport camera didn't catch, they could see details from our smartphone photos. So that's another thing you can do is you can link external data to this thing to make it more intelligent. That was really useful. To your question, other industries that we've
well, let's stay on hospital for the moment.
Yeah, okay, that sounds.
So, and I'm not asking for a name and a name of an individual, but who's the client at a hospital? Is it the architect? Is it the general contractor? Is it the
owner?
It's the owner of the hospital. Great. So, what problem are you solving for the owner of the hospital?
They just want their remodel done so they can get new equipment in quicker, faster, smarter, cheaper. And so I was approached by 2 different general contractors who won 2 different hospitals. So we did 2 different projects in 2 different states. But the idea there was they wanted a way to share the data and to understand the space, and they wanted a way to take rough measurements. And
they meaning the general contractor, or they meaning the owner of the hospital?
Well, it's a collaboration. So the owner says, this is what we need done. And the general contractor decides how they're going to do that. Mm-hmm. And then the general contractor decides, who's going to work on that project, and as far as all the subcontractors. And then they made a decision how we should 3D scan this whole space because they already knew 3D scanning is a great technology. But then, so we offered 2 costs. We offered the cost for the 3D scanning from the Lidar and then the Matterport. And the cost was quite a bit different, right? So Matterport was probably a quarter of what the laser scanning would have been. Mm-hmm. So it's a really, for them, it made a lot of sense. It still was a good paycheck, for everybody involved. No problem there. Totally livable if somebody had a business doing this.
Let me stay on the owner. I want to follow up on this. So would the owner of the hospitals say to the general contractor, go pay for a scan, we would like to have that, it's going to be helpful to us? Or is the hospital saying, we're going to go ask 3 architects to bid on this project, and we want to hand them the 3D model, the as-built, along with the data, so that they're not trying to recreate the world, even to quote on a project?
It depends on the client. Some clients want to be owners, really want to be involved in the project, and they have a plan on how they want to accomplish that project. And sometimes the owner says, I don't care how you do it. This is what we need done. Figure it out. And so I've been approached by both an owner's rep and by the general contractor and by the architect. And oftentimes when I teach them what the technology can do and what it can't do, then they'll take that information back. I'll write a proposal and I'll say, this is what you get. This is the accuracy. This is a sample of what it would look like. I send them a link, to my Matterport model of something. And then they take it to the owner and they get the owner's buy-in, which is a stakeholder, right? The owner says, oh, that's cool technology. That could, serve us in a lot of different ways. And will it meet the goals of the project? And the GC will say, or the general contractor will say, yes, it will. Great, we'll pay for that. So then it's approved in the budget. Then they say, when can you start? And that's when I get to go to the field with my crew and start the deal. But sometimes, but that's a bit of a moving target when you ask about that, because it depends. Again, some owners, reps, or owners will understand the tech and understand what they may even have other uses for it. Sometimes they even just use it for marketing and to show a before and after. So they say, we want you to scan now, and then we want you to come back in a year and scan it again.
So certainly the architect would probably be way interested in that, to be able to say the before and after, particularly if they're quoting on new projects where somebody's not even going to be in town to visit work that they've done.
Yeah.
The general contractor may want to be able to have people walk through projects that they've done. I want to go back to the owner though, and I love that it's a moving target, because it can happen anywhere. So from an owner's perspective, or the owner's rep, they may want to have Matterport done even before they talk to the architect, even before they talk to a general contractor.
Right. Yeah, that's right. And I have had that.
So that would be a stakeholder that has a problem, which is, we're going to go put this out on bid with 3 different architects, 5 different architects, and we don't want them all showing up with laser measurers and taking pictures and reconstructing the space only to come back with a proposal. We want to fast track them to have an as-built for doing their sketches and their proposals for us.
Yeah, and it depends on how the owner's rep or the owner is staffed up too. So we worked with Metro for a short time, which is in Portland, and they're in charge of the convention center and the Rose Garden Arena, the Moda Center, where they have basketball games, and all these different properties that are really high value. And they actually learned about Matterport because they had their own little kind of technology team and marketing team on staff already. So they figured out what they wanted before they even looked at a general contractor or somebody to help them with this project. And so they wrote the proposal to mandate basically Matterport into the project, but they didn't call it Matterport. They just said we want a 3D model of the space that can be shared on the web. And they basically wrote every spec possible that matched the language of Matterport, but they didn't say Matterport. Because they said, we want everything that does, but we can't call it that, because we have to say, they have some policy where they're not allowed to say you can only use this specific technology to get to a goal. They say this is the goal and this is exactly what we want it to look like, but if there's other technologies that do it, then that's fine. So that was another way that it's come across our fleet.
Yeah, I mean that's so helpful, because now if you're a Matterport service provider and you have the opportunity to talk to the owner and be able to have this your specs for what you do written into the requirements for the general contractor, that sounds way cool. Let's move over to the general contractor. Why does a general contractor want a Matterport scan?
Well, like I mentioned before, they want to be able to share it with their subcontractors so that they all know what's going on. But they also want to use it for planning. So one project we did called Bean Hall down in University of Oregon, they had all these piping systems in this historic dormitory that they needed to save some and remove some. So I asked them to hang little colored ribbons, coated ribbons. I said I couldn't probably read text on them, but I could see color. And hang them, like green is destroy, red is keep, or however engineers like to do that. It's kind of reversed. And so we went through and scanned it with the Matterport, and then they were easily able to see, remotely what needs to be done. And so they were making changes to their design models based off the Matterport model to some degree. We also 3D laser scanned it with a Faro scanner, and that's where we did that cloud compare analysis, where we compared the terrestrial laser scan data to a Matterport and saw how those match up, as far as accuracy goes. And I did a little YouTube video on that comparison, which has had, I think, 20,000 hits or something.
What was your conclusion? First, your YouTube channel is?
It's just Topa 3D YouTube.
Okay, so that's Tom, Oscar, Paul, Alice YouTube channel. Topa
3D.
3D. That's 2 words. Topa is 1 word, and then 3D. Topa 3D.
Yeah, all runs together on the YouTube. If you type Topa 3D YouTube, you'll find it.
TOPA 3D, and then you can see that. Give us the short answer. How did Matterport compare to a Lidar scanner?
So the short answer is it's not as robust. It didn't pick up reflective surfaces very well or the dark pipes at all in some cases. But what it did do is in small rooms, it was almost just as accurate. It was within 1/4 to 1/2 of an inch, where the Matterport scanner didn't have a lot of room to move around. We might have gotten 10 scans. It was very accurate in a sort of a cube room. But when you stretch that Matterport scanner over the length of a building that was almost the size of a football field, it kind of drifted, and you saw that there was some inaccuracies on one end or the other. So they never could fully line up to the Faro scans.
Are there some industry standards of how people refer to accuracy in the AEC space?
We call it measurable precision. We call it tolerance. What's your tolerance of the project? And a lot of them will say, surveyors will say 200ths, which means 200ths of an inch typically, but they'll just throw out a decimal. And an architect will say 1/8 of an inch, and a general contractor can be somewhere like millimeters or 1/4 of an inch. They talk like architects. So depending on who you talk to, but you need to be able to say, how accurate do you need the data? Some version of that when you're asking to work on a job like that.
LOD?
Level of detail. So level of detail is a modeling term in BIM industry. So BIM stands for Building Information Modeling. Some have said Building Information Management. But the idea there is it's a building and it's a model, and in between is information. So that's where that Revit modeling comes in, but it's much more than that. The information they need to know is, schedule and all these other sort of analytics that go into a project. So a BIM is really a process of coordinating multiple subcontractors, designing how the building's going to fit together with all the different systems. And when they do the coordination before the project even breaks ground, they're verifying that this pipe isn't hitting this pipe in the 3D model, and that somebody moves their pipe so that once.
Is there a term for that?
Well, they call it coordination, or they could call it clash detective or clash detection in the industry, because that's a tool that's built into the primary software that uses that, called Navis.
So who would know that when someone creates a BIM model of what's supposed to be built on top of the as-built, that while somebody's building, it creates a conflict with maybe the electrical, the plumbing,
right.
where the words often are used as clash detection.
Clash detection or clash detective. So the way this works typically is a reality capture service provider will go scan a space with some kind of scanner, even a Matterport. And then this might be a good segue into Matterpacks, but then you can take that data and superimpose it on the 3D model in Revit or Navisworks or CAD, and see what's really there with the scans and what is there in the design. And then so the designers will then move their model to match the point cloud. They'll nudge it over and move those 3D components to match the actual as-built conditions. And then they can start their coordination process. That's the idea.
I don't understand how that's done. I shoot Matterport and I get a 3D tour. How do you do clash detection with?
Yeah. So the really great thing that Matterport has done is they also pull out a point cloud from the scans and the photos that are taken from the Matterport camera. And they bundle it. It was a beta program, but now they're bundling it into what's called a Matterpack, which is $49 per model. And the Matterpack contains in it a point cloud, and you can download it as soon as your model's processed. It's immediately available for download. But when you do it, you have to pay through your subscription, right? So for $49, you download it. You'll get a reflected ceiling plan, which is like a photo snapshot of the entire ceiling of the entire building in one photo, like an image, right? And that's good for architects to know where all the lights are, so they can determine where all those lights are, and other ceiling sort of information. It's like a map of the ceiling, reflected ceiling plan. And then you also get a floor plan. And that's different from the schematic floor plans that you can download separately on the Matterport website. This is actually these ceiling plans and floor plans are actually generated from the point cloud. And then you also get a XYZ file. It's called cloud.xyz. And you get an object file as well, which is a 3D mesh model with all the textures that you can pull into like visualization software like Blender Game Engine or 3D Studio Max or Maya or something like that. But the point cloud, the XYZ, and those two plans, those are really valuable for AEC. So the point cloud is something. They give you the most basic form of the point cloud. It just has the XYZ coordinates of every point. So what they're doing is they're generating a point model from the mesh model that was created from the Matterport camera. What we see when we're looking at the mesh model on the Matterport cloud is not as high a resolution as what's originally generated. We get kind of I guess a dumbed down version of that model when we see it. But the actual model is actually very, very high resolution, and it's picking up very sharp corners and edges, and it's not really bubbly like you'll see when you're looking at the mesh on the dollhouse view, for example. So
you mentioned earlier that the architect standards seems to be working in AutoCAD Revit. Mm-hmm. Matterport's providing a .xyz file. Can that .xyz file be imported into our Revit.rv? An RVT file?
Yeah, that's right. So there's a conversion process. So when you take that XYZ cloud file from the Matterpack, you can import that into a software that Autodesk makes called Recap. It's free, and you can download it from the Autodesk.com website. And you just drag and drop that XYZ file in there, and it converts it into what's called an RCP file or an RCS file with an RCP file as well. All that means RCS is a recap scan, RCP is recap project file. Anyway, those work in tandem. So you convert it into this format called recap, and then that recap file is now a point cloud that can talk to all Autodesk software. So you can import that point cloud now into Revit, into Navisworks, into AutoCAD, into lots of different platforms on Autodesk.
And then once you've imported it, then you can save it as a Revit file, for example.
You could embed it, but it actually is kind of like a link, an external link. The best practice is to link it to the model. You just link it there, and then you can move it into place, and then you can perform that deviation detection between the model and the actual point clouds.
Okay, so remember, I'm a Matterport service provider. I'm a newbie. I got my camera. I'm hearing these words for the first time. So when the architect says, can you give me a Revit file? The answer is I can give you a cloud.xyz file that you can bring into Autodesk Recap, and then from Recap, open Revit and point to the recap file. So there is an interim step of going from Matterport to Revit, and there is a path. You just need to know some of the lingo here, which is the architect's going to ask you the question, can you give me a Revit file? And before you say no, the answer is I can give you a file that can be imported into Recap so that you can use it within your Revit platform.
That's right. To some degree, that's true. So can you give me a Revit model? If they say that, you can say, well, we can give you a point cloud, which you can visualize in Revit, but the modeling part, what they're asking for is actually a vector model rather than a point model. That's going to take some work. You have to actually create that and trace the point cloud potential.
Do you know any companies that would provide that service?
Well, we do. We're one, but there's many.
Stop there. So that's topa3d.com. TOPA3D.com. So if you get stuck and someone says, no, I need a vector file, and you're scratching your head, well, how do I convert to a vector file? You send Paul an email, call Paul, send up a smoke signal, and he can provide the interim solution of that file conversion. Yeah?
Yes, or teach you how to convert it to, at the very least, to something that other CAD platforms can talk to.
Okay, but I'm going to assume that I'm a Matterport service provider. I bought the camera because I like the fact that I could take pictures. The fact that there's this thing called Matterpack, Matterpak, scares me because I have no idea what this reflective ceiling and this thing at the bottom and this XYZ. But if I just know enough words that if the architect's asking for a Revit file or is asking for a recap file or asking for a vector file, the answer is one way or another, you can provide what they need. It may cost you some money to engage Paul to either Topa 3D to either do the conversion for you or to provide consulting services to you to help you make that sale, because Paul knows the lingo to help you through that critical point.
Yeah, and the process of how to take it from downloading the Matterpack and how to feed it to the AEC industry and know what they're asking for and know the path to get there.
Okay, got it. So is there anything else in that Matterpack that matters?
That's the most important pieces is the object file. Like, you can take that object file and you can drag and drop it into Unity game engine, or Unity visualization, so you can do VR with it. So I've actually been able, in my LinkedIn learning course on Matterport, I show how you can actually take Matterport data object files from that Matterpack and pull it into Unity and texturize it and then view it in VR and create your own video game around it if you want to. I didn't go that deep, but I can show
for the purpose of on today's topic, though, on the show, somebody in the AEC space, if you told them you had a .obj file, an object file, they would make their eyes glaze over and they'd have no idea what to do with it.
Not necessarily. A lot of people in the AEC space understand models of different kinds, but I think they'd be more interested in the point cloud.
Great.
That's going to be what matters.
That's what matters about the Matterpack is the XYZ file. So let's just go back to general contractor for a moment, because it's I want to say that's where the money is. The general contractor has a lot of money. So, yes. So the question is, I'm going to start with, how do you help the general contractor save money? So pain point. How do you help a general contractor save money?
Creating the as-builts. That's the shortest answer I can say is going out and creating those as-builts for them. In other words, making a 3D map of the existing space. And if their tolerance is a couple of inches or worse, then that's a perfect storm for Matterport. It's a perfect place to use a Matterport camera. If it passes security, as far as cloud protocols, if the accuracy isn't too tight, millimeter is a little too tight for Matterport. And the third thing is you need to have insurance. So you need to be able to get into a project site. So every single project site requires a service provider to carry umbrella insurance, liability, sometimes professional liability insurance, general liability, and oftentimes that starts at $1 million. So to be in the AEC space, to be able to play in that world and to do those projects, you have to know that you're going to be wearing a hard hat. You're going to be wearing safety boots, a safety vest, gloves, and safety glasses, both personal protective equipment, PPE. And you'll have to have the proper insurance based on their needs. And that insurance is going to cost you between $3,000 and $6,000 a year. So that's kind of the basic requirements to get into this industry.
Now that seems, I know we carry, I want to say, general liability insurance for $2 million, but I don't think our premium's anywhere close to $6,000. Is that related to a commercial construction scanning?
Yes.
Versus a home scanning?
Right.
Interesting. Okay. So the cost of entry can be quite large. Is it possible to be a sub for someone else that carries the insurance?
An employee. But
an employee, also, but not as an independent contractor.
Typically, no. Almost everybody that comes onto that site as a subcontractor has a minimum insurance requirement. So you'll just need to look at that for the project.
Okay, and I would imagine one of the ways perhaps around that is to say, hello, Topa 3D, are you able to engage and scan. And so essentially I develop the business, but I bring somebody else in to do the actual scanning that has the appropriate insurance and also has the gear. I realize the gear is not that much, but I guess we should say for a Matterport service provider, you're not going to be able to walk on the job site without that safety vest, that hard hat, the shoes, etc. And that comes out of your pocket. So you got to figure, they're not loaning you a hard hat and a vest. You might, but you figure you got to buy some stuff. It's not going to cost you a lot, but you got to buy it.
Yeah, with the camera and the gear and the insurance all in, you're going to look at $8,000 to $10,000 probably per year to get into this business. Mm-hmm. And so, which isn't too bad. I mean, it's $8,000 the first year, and then the next year it's only going to be your insurance cost, which is you have the camera already.
Yeah.
I think the other thing to keep in mind is you have to bid these projects higher because you're overhead. And these jobs often require you traveling quite a long distance. It's not just your neighborhood. It's going from state to state sometimes. And, to do this business seriously, I think you really need to consider raising your prices from real estate to construction. So we add on about 25 to 50% more to do the construction jobs than the real estate. Sometimes we've gone up to 3 times as much. Just because of the logistics to make that happen and to cover those expenses. And these projects can take more than just one day. They're not just in and out, like I mentioned, some of these projects are quite large.
When you did the hospital and, let's say 160,000 square feet, could you do 20,000 square feet a day?
Yeah, we were doing between 20 to 30,000 square feet in a day per camera.
And so then you needed to do a calculation to say, how many scan days is it going to take me? And then I imagine that you also figured that worst case, you're not going to be allowed into certain spaces at certain times and that you'd have to come back and
Yeah, this is really great. It's like you're reading the whole project scope. So what we ask for in the scope is we say, this is how much time it's going to take. This is the cost. Based on what we think it'll take. But also, if we don't have building access, then we have the right to a change order. In other words, we can increase our costs if we can't get access. And that's exactly what happened. We didn't have access to the pharmacy because it was very secured and they had to have an escort. Some of the closets were just locked. Nobody had a key. So we had to come back like 3 times. And so we have to think about the per diem as well. How much does it cost for meals, lodging, and incidentals to take that trip to go there to do this job and come back and so forth, mileage, whatever. So you have to take all that into consideration. But in your contract language, really make sure you point out that sort of disclaimer that says, if we don't have access, then we have the right to raise our price, to take care of that. Because you can start losing money very, very quickly on these large jobs. Especially if you have an employee who's getting paid hourly or something that's going to have to stay out there another couple of days. If you don't have budget for that, then you're going to eat it. So it's important to think about that.
Tremendous. I mean, these tips are just they're golden. Thank you for sharing these, Paul. Just awesome. I want to go back to the general contractor, and I'm going to stick with as-built. So the general contractor pain point is having an as-built for who are the other stakeholders that find an as-built helpful.
So we've done a project for building forensics. There was a construction going on next door to a building that had historical value. And they wanted to make sure that when that was happening, their walls didn't get cracked or something, because it's just some sort of unreinforced masonry brick. In any case, so we Matterported the whole basement foundation area. And so they had kind of an unlimited amount of photos of all the brickwork that was exposed down below. And they just used it as an insurance policy. We didn't actually really do anything except scan it. And they want us to scan it again when the project's done so they can compare the images, and some of those applications we can scan from the same position, doing that over and over again so that we can kind of see roughly changes over time from that vantage point. Mm-hmm. That's another sort of application that we ran into as well.
So does the electrical people find it helpful, the plumbing people, the mechanical, or they really care about the BIM, and so it's the general contractor who cares about the clash detection among the trades?
Right. The general contractor generally coordinates that clash detection and making sure that everybody who submits a model to the master model, or what they call in the industry the federated model, like a starship, the federated starship, when they put all their models together, and they have to make sure that they all fit. And sometimes they just smash into other ones, and they have to figure that out before they start building the building, because Revit has this capability of, when you build the model, you can actually make 2D prints directly from the model, right? It creates sheets or architectural plans and sections and elevations directly from the model. So the model needs to be, accurate and how it's going to get built. And then they distribute that data to all of the subcontractors to start building from. So yes, the general contractor is concerned about that. I don't get a lot of calls from the trades, like the MEP sort of folks, or painters or carpenters. But I have got jobs where for disputes to builders, like I said, forensics on that one case. Another case, I work with a client who multiple times we've been called in to scan a house, a residential, or even commercial, and show in 3D and also with the photos what the problems are with the structure. And they've actually used it in court, and so they're able to see like hundreds of photos from all these different vantage points. Whereas doing it with a camera is kind of tough, unless you maybe have a 360, like a Ricoh Theta camera. This is just a much easier way, because you can go from dollhouse and say, I want to see that room, and dive right in,
Mm-hmm.
the dollhouse. And those sort of things just settle almost right away, because they're like, well, we see everything, there's kind of no dispute here. So that's the end of that talk.
Cool. Are you using Matterport for construction progress documentation, or no, really as built? That's going to be Matterport's sweet spot.
Well, as-built is good. The accuracy though for as-built usually is tighter than what Matterport requires. So we have to be careful when we talk about as-builts, in that it's a lot of times they need that 1/8 inch or that 1/4 inch tolerance for as-builts, especially mechanical, electrical, plumbing as-builts.
But would they do the scan twice? Meaning, let's do Matterport initially. That'll get the architect being able to sketch and design and propose. And then once we get going, we'll bring in the Lidar scanner to actually do the heavy lifting.
That is a possibility too. We've done both. We just finished a project where we scanned a tea house that's getting remodeled, and it's like 3 stories tall. It's pretty big, and they actually did that. They took the point clouds and they used it as a rough-in for the as-built. We actually scanned outside. We scanned just after dawn, before the sun comes up, or before dawn rather. So there was ambient light, so we were able to scan the entire outside area with Matterport, and it looked great. So there's some ways we've been able to trick it to do that kind of work. And we gave them the point clouds, and they were able to work with some of that. Although we had to rescan the outside because there was some inaccuracies on the backyard. So we used a Faro scanner for the backyard on some of those areas.
A Faro scanner is what? Faro
is a terrestrial. It's a brand. It's a terrestrial scanner. It creates Lidar data, very accurate Lidar data.
Lidar is?
Point clouds. It's light detection and ranging. Sorry. So it's a laser.
Can we call it a super high-end scanner?
Super high-end scanner is a great word for it.
And how much do these things cost?
Well, they range from about $20,000 to $150,000, depending on the type you want.
Okay, so it might actually pay to do Matterport first.
Yes.
And then because I would imagine if you're renting or owning a machine that costs $20,000 or $150,000, you're going to be charging a lot more. And therefore, maybe the first phase of the project really is an as-built for the architect to do the initial sketching. So if you get the owner, if you're lucky enough to get the owner, then they may very well go for the Matterport, because it gets the process going for the architect totally to be designing. And then once the architect is selected and the general contractor I'm presuming the architect's done before the general contractor. Do they both get hired at the same time or not necessarily?
No, well, the architect is a lot of times before the general contractor comes on board. Yeah.
So, and the architect actually may be able to afford to do Matterport because it's replacing them sending people out to do the laser measure and take pictures and reconstruct the space. They don't necessarily want to pay for the Lidar scanning.
That's exactly right. And that's exactly the right application. You said it very well, Dan, is that in that pre-design or early design phases of the project, Matterport is where we get called in to do that kind of work, because it's that rough-in kind of measuring and understanding the space, to do some preliminary assessment, to do kind of whether or not it's feasible, like a feasibility assessment to remodel this thing. Is there too much damage? It's just a really nice way to capture that space and understand it. And then exactly right, when they're ready to go full on and get those accurate as-builts, then they'll switch over to the Lidar, the light detection and ranging terrestrial laser scanners that are more high-end to get that accuracy. But Matterport is a great tool in the toolbox. It comes early in the phase. And sometimes it comes later too. It's hard to say, it's not always predictable, but that is a little bit more predictable in the beginning. Yeah.
Well, I also hear you at the end. If I'm the architect and the project's done, I'm going to take 2D photos is probably how it's been done to be able to show in a paper portfolio or online. But now imagine you come back with Matterport and scan the entire finished project. And the architect is able to show it off. I actually wonder where's the money. So if you scan the project at the end, is that something that the owner, the architect, and general contractor might share the cost in, because they all have a reason to have the finished product?
Well, what we get contracted to do is we get the full contract in the beginning, and they break it in half. They say we'll need a scan at the beginning, and they've decided they need a scan at the end. And so we sign on to a contract, we'll say $6,000. And so we bill $3,000 when we're done with the first half, and then $3,000 when we're done a year later with the second half. So that usually comes, at least in my experience so far, it all comes up front in that sort of dialogue. But we have had calls on the back end to have something that's been done already, because they just want to showcase it. Mm-hmm. We did a furniture design store, and that was a really neat project because it was already done, and they just wanted to showcase all of their wares, So that's another thing. So I guess there's a lot of ways you can look at it, but typically we've seen contracts come all at once and tell us how the whole plan is going to work all at the front end.
Mm-hmm. So I think part of my takeaway here, and you talk about owners, architects, general contractors, subs, that if you're lucky enough to get into the owner to the owner before the project moves to an architect, that's way cool, because you either get scoped into the project, or the owner just simply decides, I'm going to go buy this because I'm going to ask multiple architects to go do proposals for me. And then second, maybe to be chasing after architects, because the architects don't really necessarily care, about the level of accuracy, level of detail. They care about, is it a 3D model that I can build on top of to propose a design?
Yeah.
And the general contractor, that one may be a little bit of a challenge because their level of accuracy requirements at that point may be that they really do need the Faro Lidar scanner level of accuracy.
Or Leica or ZNF. There's a whole bunch of scanner models out there. But I will say that that's mostly true. But the general contractor also would want, like I said before, to share that data with their subcontractors to bid.
Yeah. So, and it's way easier to share. So I think you even used the word democratization, that Matterport democratizes all the people to be able to, all the subs to be able to view and measure, because whether they're using an iPad or they're using a desktop or a laptop, you can look at Matterport running in its own 3D showcase player, as opposed to talking to the painter guy. And if you said, hey, I want to send you a Revit file, they'd have no idea what you're talking about. All they know is they want to come out and measure the walls to calculate. But now you can give them Matterport, give them access as a collaborator for them to do their own measurements without having to come. So it's democratization, enabling the subs to be able to quote on a project without necessarily having to everybody measure the same space over and over and over again.
You know, and Matterport is about 5 times faster than a Lidar terrestrial scanner. It's just so much faster. You're getting, 20, 30-second spins. Granted, you can only jump about 5 to 8 feet between scans, but I've even jumped a little further and got away with it. And but if you're doing a space, you don't have to jump that far because it's so many rooms. You have to jump that way with a terrestrial scanner as well. So speed is, to get through 160,000 square feet with all these rooms that we had, in the speed that we did it, would not have been the case with a laser scanner. It would have taken probably a couple of weeks and a lot more cost. So it was just a really great, fast, inexpensive way to get some sort of mind wrapped around that space.
Mm-hmm.
And I want to say I'm really excited. Go ahead. I'm sorry. Go ahead.
It's okay. It's all right. Go on, Paul.
Well, I'm really excited because this the object file and the point cloud and those things that are generated from Matterport from the Matterpack. There's a new software out there that's coming on the market full steam called Revisdo. And Revisdo is kind of like Navisworks software, which does that clash detection. It's like that combined with, it also has virtual reality functions where it can go into VR. It's a really great kind of general contractor or construction-based software that can visualize BIM models intelligently. And it works on iPads and everything, but it also accepts object files, OBJs, meshes, and it accepts, it's going to be accepting point clouds in the near future, as far as I've been told. So this will allow us to see in situ, the model and the Matterport model sort of superimposed on each other in 3D space on an iPad for construction professionals. And I think so Matterport really did a smart thing in that they made their data sort of interoperable with all these systems. Even if the accuracy is not there, you still have some really important functionality.
Yeah, that's awesome. It sounds like that's the Revisto is going to add huge value to the Matterpack, to the Matterport Matterpack, as using that object file. I was going to ask you about facilities managers. Does that fit into any of your the project's done? It's being turned over to whoever's managing that property. Does Matterport fit into that? Any of the work that you've done?
No, not really. I haven't, but to be fair, that's not something I've done a lot of work with. Most of the work we've done for facilities managers, we've done some work with some government agencies. They're most interested in having a low-tech photography solution that just kind of documents what they have, and they want to be completely offline. A lot of them don't even have access to the internet while you're at work there.
Got it.
So Matterport's kind of off the table for some of the facilities managers, clients we've seen. That's not to say that some more progressive facilities managers who do want cloud solutions wouldn't be open to it.
Mm-hmm. All right, Paul, before we wrap up, I want to do if you don't mind, a lightning round with you. I'm going to give you some jargon and you tell us what it means.
I'll try.
Okay.
Okay.
RFI.
Request for information.
What is that?
So it's like a proposal, but it comes from, maybe a professional like an architect or a general contractor, and they want to know, can you provide, it's kind of, there's request for information and there's a RFQ, request for quote, but it's not a formal proposal. They're not saying we want you to bid on this necessarily, but we want to know what you're capable of, what this project might need. It might be a document that goes out to ask for technical information on how to accomplish a project. It could just be a document that asks some sort of question about the existing project. We need to know what this RFI is going to be resolved or not. Is this pipe supposed to be here or not? And then whoever's responsible for that pipe needs to answer that question. So it's a request for information. It can be very broad.
So if I'm a Matterport service provider, I call up the owner of the building and I say, hey, I got this thing that does 3D tours, blah, 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 blah. And they say, great, we'll send you an RFI. We now know that they're not asking you for a quote. They're just kind of kicking the tires a little bit to understand what it is that you're capable of doing.
In that situation, that could very well be true.
Okay, RFI. RCP.
Well, RCP could be a reflected ceiling plan, or it could be a recap file. So a reflected ceiling plan is, like I talked about in the Matter Pack, it's basically an ortho photo or all the Matterport images stitched together to make one full ceiling of the entire building that you scan as like a map, a 2D map.
That was going to be a trick question, and I got two different meetings. So let's go back into recap. Recap is?
RCP is the name of a file type. Recap is a conversion platform to take Matterport point clouds, in this case, and convert them into something that Autodesk software can use. You can also convert Matterport point clouds into Bentley software and other CAD platforms out there on the market. But Recap is just really popular.
Autodesk.
Autodesk, they're the makers of AutoCAD. They're the makers of Revit architectural software. They're the makers of Navisworks. They're the makers of 3D Studio Max and Maya, which are animation software platforms they use for movies like Toy Story and things like that. So
my general contractor in the house today said, can you give me an Autodesk file? How do I reply?
You need to ask him, do you want a CAD file like a DWG? Ask him what the extension of that file should be. DWG, RVT, what do you want? Revit files, Navis files, a CAD file, like what version of Autodesk do you want?
Okay, great. So that's good. I got to push back and get a little bit more detail about which program, which software, since Autodesk makes so many different packages, which Autodesk software he or she is using, and what is the file extension, and it's going to have some three-digit letter like DWG file.
Yeah. Yes,
I won't even ask what that stands for, but that's what you want to know. It's a DWG file or a .rvt file or a .skp file. Right. Push back, ask them what letters. Let's see, Civil 3D.
So Civil 3D is an Autodesk software platform, and it's designed for civil design. It can take very large files. It can make topography maps. It can make contour lines. You can do section cuts, volume calculations. You can do all kinds of things, anything that has to do with moving dirt, building roads, planning an entire project site with trees, all that kind of stuff is really kind of where Civil 3D shines.
Cool. I want to ask you a bonus round here. Many of our We Get Around network Matterport service providers are drone pilots as well. So what's the opportunity? Say, okay, I'm going to be now I know to talk to the owners, the architects, the general contractor, and I also do drones. So what do I want to talk to them about? Why would somebody want aerial?
Well, construction progress is a big one. To be able to take a shot, aerial photo of the project site every month or every week or something like that, so they can show the building going up from the same vantage point is really, it's like a time lapse from the sky almost. So that's really an advantage point. The other piece for drones is to map the site, to make a 3D model of the whole site, so they can pull a topography, make contour lines, and know the actual landscape. So as a reality capture service provider, which is a good way to brand yourself if you're going to offer multiple capture technologies, is just call yourself a reality capture provider on some level. And then you can do the interiors with the Matterport, you can do the exteriors with the drone, and really give them a sense of that space.
And am I doing that with a particular, Pixel 4D?
Yeah, so I actually I use Pix 4D, which is
PIX 4D.
That's right, and it's $350 a month or something like this with no commitment, so you can just do it 1 month and never do it again with no cost. and it processes your data in the cloud if you want, or on your desktop. The cloud is much faster, and it's very powerful. If you're using DJI products or unique products, any of those, even Falcon 8 or some other drones that are more high-end, it'll process just about any camera on a drone on the market to date. Great software. I also use context capture, which is made by Bentley Systems, to do 3D models of buildings. Very, very accurate building reconstruction from photos. So that's helpful as well. And I've actually linked the Matterport model through a Matter tag to the drone model that's hosted on my Amazon server as well. So they can walk through a door and hit the Matter tag and go into the 3D model of the entire property as well. So linking those data sets is pretty awesome.
So that sounds pretty cool in terms of doing it with the Matter tags, but I would imagine if you're in the data view, there's some way, some program that you can mash the two up, the data from the drone and Matterport data. Is that happening?
Yeah, so you can take the point clouds and you can combine them using software like any of the Faro scanning software or the Leica Cyclone software. All these scanning processing software platforms can combine point clouds in unique ways. You can move them around and match them up. Cloud Compare is open source and free Lidar or point cloud software. It accepts point clouds from Matterport or any other drone-based point cloud. It doesn't matter. So, and then once you get those point clouds together, you can mesh them, and make a model if you needed to, or just trace them out in Revit and make a Revit model. You can do a lot of things with point clouds. They're very versatile. So I'm kind of a fan.
Wow. Were there other projects? We focused a little bit on hospitals, but were there other projects that you wanted to talk about?
Well, we've done ADUs. Just
ADU. New. We didn't do that in the lightning round. What is that?
That's okay. Well, essentially, what it is it's kind of it's a unit, a smaller unit, like a housing unit sort of thing. The acronym's actually escaping me at the moment.
Okay.
As far as what it stands for, but the idea is small housing units. I just did a ADU, which is it's like a tiny home for a developer who's making these tiny homes for people with low income, so that they can have a place to stay with a low cost, and people are putting them in their backyards and renting them out for a few $100 a month or something.
Airbnb.
Yeah, exactly, right? So Matterport's a great way to showcase some representative tiny homes or ADU kind of establishments. There's just a lot of different ways we've used this, but the main message we've been able to use with Matterport is to share what the space looks like, to help people wrap their mind around it, especially complex spaces. And then, of course, real estate, they just love using this for marketing. It's just a really easy platform for them to share.
Awesome. Before we wrap up, anything else we missed that you wanted to cover?
I guess I'm just really grateful. Thanks for interviewing me today, Dan. It's been a delight, and I love talking about this stuff. And if you have any questions about the AEC industry to your listeners or whatnot, please feel free to contact me. I'm on LinkedIn, and also you can reach me on topa3d.com.
So on LinkedIn, probably the easiest way to find Paul Tice, T-I-C-E, Paul Tice, is to put in Google Paul Tice, Topa 3D, LinkedIn, and then because it'll find the right Paul Tice.
That'll be the one.
Yeah, and frankly, Paul's everywhere, so you can find him on your YouTube channel. That's Topa 3D, all solid. Just Google YouTube, some amazing videos. On your website, Topa, T-O-P-A 3D.com. You have an amazing, I want to say, blog, which goes into some very extensive level of details. I think that was one of the ones you did on the comparing the accuracy of Matterport to a Lidar scan. And that video that I think you had 20,000 views that you mentioned has a companion blog post that goes into great detail. That's awesome. So Paul, thank you so much for being on the show today.
Yep, I love to teach, so feel free to reach out. Thank you, and you have a great day at it, Dan. Thank you.
Yeah, thank you. So we've been visiting today with Paul Tice. He is the founder and CEO of Topa 3D, Topa second word is 3D, TOPA 3D at the website topa3d.com. Paul is, as I mentioned, is the founder and CEO. He's based in Portland, Oregon, though presently working on a lot of work in the Central Oregon Oregon area. That the name of the location would be
Bend, Oregon.
Bend, Oregon. Paul has been so kind to share with us. I think you can see why he is has a course on lynda.com in the LinkedIn learning community, does consulting in this space, does scanning with Matterport scanning at high end, does training, does teaching, does consulting, and I think I've sat in on some of your programs at SPAR 3D Expo and Conference. So he's really, very well respected in the space, is a journalist on top of everything else, writing for Lidar magazine and for SPAR 3D as well. So we've been talking again with Paul, specifically for Matterport service providers of how to make money with Matterport meets AEC space for newbies. We've covered a lot of ground. I think Paul has shared actionable information with you of helping you, identify who the stakeholders are, what's important to them, know the lingo of how to talk to them. If you've tuned in late, we've recorded today's program by tomorrow, Friday, September 28th, 2018. We'll post it in the We Get Around Network forum. So check it out. So Paul, thanks again. Good to see you. Good visiting with you. Much appreciated. And thank you all for tuning in. I'm Dan Smigrod, founder of the We Get Around Network. And you've been watching WGAN-TV live at 5.